Hey guys, I want to go over with the homework with you, make sure you feel comfortable, and that's going to really set you up for the next day. So I didn't actually make you do 11, but you should still know 11, so I'm going to start there. An atom in the lowest possible energy state is said to be in a blank state. So remember how everything starts in, and then if it gets energized, it hops out, okay, hops out to a higher layer. So that bottom layer was called a ground state. Hopefully you have that down, a ground state. Move on to 12 here. So 12. When an atom is excited to return to its ground state, what happens to that excess energy? Well, so it was all excited, hopped up, right? So when it comes back down, it releases that energy, and often in the form of a photon. Okay, so it's going to give off photons there. Or release that energy. It kind of turns into, which is light, or in the form of light. That's a great answer too. 13. How is the energy carried per photon of light related to the wavelength of light? Okay, well, the answer is the same. Okay, so, well, kind of. Okay, so the energy per photon. So remember, the more higher the frequency you have, the higher the energy. So if you have a lot of energy, you'd have a shorter wavelength, okay? So the more energy per photon would be a shorter wavelength. Does short wavelength carry more energy or less energy? And so it kind of repeats it, yeah. So a short wavelength would have more energy. So 14, when an atom absorbs energy, it goes into a blank state. So what was it called when it absorbs energy? Well, it jumps up, and that's the excited state, okay? 15. Describe briefly why the study of electromagnetic radiation has been important to our understanding of electrons. It gave away that all these different energy levels. Okay, so we discovered that the electromagnetic radiation helped us figure out that atoms have different energy levels. Okay, and by different energy levels, we're showing currently by different rings. So the electrons aren't in the same spot. Some are higher energy levels, some are at lower energy levels. Okay. And by how much they hop up or down and so on by the photons they release tells us where those energy levels are. We just did 15, so we should jump down to 18. How does the energy possessed by an emitted photon compare to the difference in energy levels that gave rise to it? So what that means is if it jumps down from a super high energy level all the way down, it's going to release more energy. And in fact, it's going to release the exact same amount of energy as the levels it jumps down. Why, if it only jumped down a short level, there's a less difference in energy. So the photon would contain less energy. So to repeat things, the energy possessed by the photon is the same as the difference in energy levels. Okay, so however far it drops down is the amount of energy contained by that photon. Okay. Number 19, what experimental evidence do scientists have that energy levels are quantized? Okay. Now, and the reason why is quantized is like quantity. It's mathematic. Okay. And the thing is that hydrogen always gives off the same exact things. In fact, each element always gives out the same exact wavelength, showing that it has the same exact energy levels, okay? And because it always has the same exact energy levels, it can be quantized or as mathematical, okay? 23. So how does Bohr's theory account for the observed phenomena of the emission of discrete wavelengths by an excited atom, okay? So Bohr actually, when he drew his model, which is the one of the different layers we learned before, the Bohr model, right? He showed those by doing different rings, okay? So different rings accounts for the observed wavelength. So at a short wavelength might be a drop from this ring to that ring, why a short wavelength would be a really big drop, because remember, a short wavelength is more energy. But the difference in energy might be between this one. So each different wave, each different color of light, each different thing emitted told us about a different drop those ones could do in there. Okay, so basically the key is that he showed it by showing the different rings. That's the big thing I want you to know. Okay. Finally, number 24, What was Bohr's theory for the hydrogen atom? Why was it initially accepted, and why was it ultimately discarded? And the problem with, so first, is it perfectly explained the motion of electrons on a hydrogen atom. The rings perfectly explained it. The problem is it doesn't work for other atoms. It just works for hydrogen. And the moment you start applying it to other ones, it doesn't. So in fact, the truth is much more complex than that. So hopefully that helps you there, and we'll get you set up for tomorrow, which we're going to introduce the wave mechanical model, which is the best model so far. So thanks.